Let's take a look at this example here on cubics, where we're factorising cubics using the factor theorem. Now the first thing we need to do here is try small values of k, for example f of 1, f of minus 1, etc. until we find f of k equals 0. So if we try f of 1 first, f of 1, well, that's simply going to be 3 lots of 1 cubed minus 5 lots of 1 cubed, 1 squared, minus 4 lots of 1, and finally plus 4 there. Okay, and if we simplify this here, I'm going to get 3 minus 5 minus 4 and then plus 4. So in that case, the minus 4 and the plus 4 cancel, 3 minus 5 would give us minus 2 there. So 1 doesn't work here, so we try another value, let's say f of minus 1. So f of minus 1. And again, we just repeat the same process here. So that's 3 lots of minus 1 cubed, minus 5 lots of minus 1 squared, minus 4 lots of minus 1, and finally plus 4 there. Okay, well here, minus 1 cubed is minus 1, and we times that by 3, we get minus 3. Minus 1 squared would be positive 1, and if we times that by minus 5, we get minus 5 there. Minus 4 times minus 1 is plus 4, and finally we've got another plus 4 there. Well, in this case, minus 3 minus 5 is minus 8, and 2 lots of 4 is 8. So in that case, that gives us 0. And that's perfect. We found f of minus 1 here is equal to 0. So f of minus 1 is equal to 0. So therefore, x plus 1 is a factor of f of x by the factor theorem. So now what we do here is we take our x plus 1, our factor, and we times this by another bracket here, okay? And this bracket here that we times it by, this will give us our original expression here, our f of x. So that's 3x cubed minus 5x squared minus 4x plus 4 there. Okay, well, what we need to think about now, using method 1 here, we need the x squared term in our brackets to multiply by x to get 3x cubed. So in that case, that must clearly be 3x squared here. Okay, if we do 3x squared and we times it by x, we get 3x cubed. So that's perfect to start with. Now we take a look at this 1 here, and if we times that by 3x squared, we're going to get 3x squared. But notice we want minus 5x squared there. Okay, so we need now to think about what do we do here to get this minus ax squared. Well, in that case, this must just be a minus ax here. Okay, because I do minus ax times x, that would give me minus ax squared. And don't forget we've got our 3x squared there. And once we simplify that, we arrive at the minus 5x squared. So we're nearly there now. All we need is our final term here. Well, to get this 4 at the end now, we just multiply the 1 at the end of our bracket here in the first bracket by a number at the end of the second bracket here to be 4. And then clearly that must just be 4 there. 1 times by 4 gives us 4. Okay, so therefore in that case what we've got now is our second bracket here. That's 3x squared minus ax plus 4. And because this is a quadratic, what we're going to see now is if we can factorise this quadratic. Well, 3x squared minus 8x plus 4 does indeed factorise here. We can write this as 3x minus 2 and x minus 2 here. Okay, so therefore, if we factorise f of x fully here now, we can write our expression here for 3x cubed minus 5x squared minus 4x plus 4 as a product of 3 factors, and those 3 factors is the original one that we found here of x plus 1. That's what we've got here, so that's x plus 1 times x minus 2 times 3x minus 2 there. Okay, so that gives us the solution to our example here on factorising cubics using the factor theorem.